Okay, good. This down here. Okay, I think I'm ready. First off, do you guys have any questions before we get started? We're going to go over 2.3, probably 2.4 today. They really should be in the same section. So any questions about anything before we get rocking and rolling? Got my favorite hat on today. Okay. Okay, let me switch it over to the notepad. Hold on. Let me find the video. Boom. There we go. Yeah. So today we're going to go over linear functions and slope. Now we'll probably go, I think we'll get through 2.3 and maybe 2.4. These two sections go together really well. So they really should be one section. But we'll see what happens as we get rocking and rolling. Okay, so I'm going to open up the chat feature real fast. And I want you to write down what you automatically think of when I say the word slope. Okay? And there's no right or wrong answers. This is just what your brain thinks of from some past math teacher that taught you about slope. And I want to see all the replies. At least a few. I need a few. Slippery, nicely done. I like that one. Colorado Mountains, yeah. Perfect. Y equals mx plus b. That's perfect. Colorado Mountains. I drove through the Colorado Mountains in a blizzard once. That was crazy. In a Prius, actually, which was even crazier. Okay, any other ideas on like how to find slope? If you want to chime in audio, that's fine too, if it's more complex than just typing. I mean, I'm going to teach it. It's not a big deal. I just want to see what your thoughts on it are. Yeah, rise over on perfect, Haven. Thank you. Okay, I'm going to start first with what Lauren said. So Lauren said y equals mx plus b, which is typically always a student says, yells this equation. Whenever I say, when I say slope, what do you think of? Y equals mx plus b. And you're not wrong. You got to realize that the m is the slope, right? So I don't know why we use the letter m. I think a lot of the other stuff was just taken, okay? But m we symbolize for slope, right? And then, yeah, really, it's slippery, and the Colorado Mountains aren't a bad way to think of it. Oh, let me put my phone on silent. Hold on. Aren't a bad way to think of it because it's really the slant of a line. That's another way to think of it, okay? Just the slant of a line. I'm going to get to Haven's response here in a second, okay? It's just a numerical way to represent that slant. So let's say we had a line. Actually, we'll do two different lines. How about that? 1, 2, 3, 4, 5, 6. We'll say this first line goes through 2, 1, and then it goes through 1, 2, 3, 4, 5, 2. And we're going to use red. So the first coordinate is 2, 1. And that second coordinate is 1, 2, 3, 4, 5, 2. Okay? And if I wanted to find the slope, the easiest way is to use what Haven brought up, which is rise over run. And the way you do that is I'm going to say the way I do it, because there's probably a few different ways. But the way I do it is I always start with the leftmost coordinate, and then I stair step my way to the other coordinate. Okay? So I'm going to take out a pen. I don't want to use a thick marker. Okay, I'm going to take out a pen. And if I want to go from here to here, I'm going to go up 1 and then over 1, 2, 3 units. So 3 is my rise. Oh, I'm sorry, 1 is my rise, right? I only go up 1. 3 is my run, okay? So I go up 1 and then over 3. I rise 3 and I rise 1, I run 3, right? So my slope for the red line, we'll use red for that. How about that? My rise is just a 1 and my run is 3. So the slope is 1/3. Now what that tells us though, and what we're going to expand on, and I'm going to tell you, if you are planning on going on to like a business calculus, or you're planning on going on to like a Cal 1 class, you're really going to need to tune into this lecture because it's so important, okay? Slope doesn't tell us about distinct coordinates. Slope tells us about change. This is the change in that line, okay? I know for every 3x units I go over, I'm going to go up 1 unit, okay? For every 3x units, I'm going to go up 1 unit. And I can keep going, right? Up 1 over 3, up 1 over 3, as many times as I want to. This should be a bit of a review, right? This shouldn't be the first time you guys have ever seen slope. Okay, so now I'm going to do another line. Let's start this line instead of 2, 1. Let's start it at 1, 2. And then let's go up quicker, okay? Let's go over to 2 and then up, let's say right here. So this coordinate is 2, 1. And this coordinate is 2, oh, I got that backwards, guys. This is 1, 2, not 2, 1. So 1, 2, and this one is 2, 1, 2, 3, 4, 5. 2, 5. I'll draw a little blue here. Why not? Now, right away, you should visually be able to see that this blue line has a much larger slant, right? It looks as though as x is increasing, y is increasing faster. We really should have used red for this one instead of blue, right? If this, like, think about this. If we were looking at, let's say time and money, I would much rather have that blue account than that red account, right? And I don't know what's happening after this, but if it goes forever in this direction, I know that blue account's going to make me a lot more money than that red account. You guys see that? So we're going to, so that, I mean, visually, that's how you can kind of see the slant of it, but we need a numerical number because that's just the way we are as humans. So if I wanted to find the slope of the blue line, if I start here, I've got to go up 1, 2, 3. And then I run 1. So it's kind of the inverse, right? So I'm going to rise 3 and I'm going to run 1. So rise over run would be 3 over 1. Now, typically, we don't leave a number with a 1 in the denominator. So I am going to write this as just 3. But realize with slope, I'll tell you, it makes more sense to leave it as a fraction, okay? It really does make more sense because it gives you the rise and the run of those numbers, okay? Questions so far? This should be a review, but now think about this. What this means is if I chose any point on this line, this blue line, like say I chose here, if I go up 3, 1, 2, 3, over 1, I'm going to wind up on the line. It's giving us the trend of this line. That's another way to think of it, okay? It's giving us the trend of the line, what's happening. Okay, now let's go over the actual equation if you're just into learning equations. So, or before we get there, let's think of what this actually means. So rise and run, the rise means the change in the y values. Delta means change in mathematics, okay? That delta symbol, the triangle, that means change. So if you see that again, that's all it means is change. So the numerator is the change in the y's, and the denominator is the change in the x's. Now, if we have coordinates, though, this is where you can bust out that y2 minus y1 because that's changing the y over x2 minus x1. So when I typically say, hey, what do you remember about slope? I always get the y equals mx plus b. And then I'll get the rise over run a lot of times. And then sometimes students will yell out the equation, okay? And nothing's wrong with that. I just need you to realize all these are the same thing, right? Or they're connected in a way, okay? So if we wanted to find the slope, since we know, let's just do that blue line and we'll find the slope with the equation. So we know the line goes through 1, 2, and 2, 5, right? And if I didn't want to just go up 3/1 and I really just liked using equations, I could plug this into the equation, but let's show how. The first thing I do is I notate it. So I'm going to call this x1, y1, and this x2, y2. You've got to determine what's your first or second coordinate. It does not matter which coordinate is first or second. It comes out in the wash with the fraction. So your slope winds up being, now the equations here. So y2 minus y1, so 5 minus 2, right? Over x2 minus x1, so 2 minus 1. So 5 minus 2 is 3. 2 minus 1 is 1. Boom. Again, I'm okay with you leaving it here, but it really is just 3, okay? And that tells us, if I'm going to interpret that, that tells us I rise 3 units for every 1 unit I run. Okay? I rise 3 units for every 1 unit I run. Now, this will make more sense once we get into actual like word problems. If we have, if X is months and Y is money, well, that means I am rising. I'm gaining $3 for every 1 month, right? That this sits in the bank account. Okay. Questions, comments, concerns? Great. Okay, I'm going to give you a few examples where I'm just going to give you coordinates, and I want you to do that. This is a good review on how to find the slope. Okay, so I'm going to give you a few examples. Let's do A. I've got 4, 2. So it goes through 4, 2, and then it goes through 1, 9. B, totally separate line. Okay, so all I want you to do for these are find the slopes. 7, 2, and then let's do 7, 9. C, let's say we flip that. Let's say we've got 8, 3, and 4, 3. So I want you to try those 3. I'm not pausing anything because I'm doing the YouTube live. Like if I do YouTube live, can you guys tell that it's on YouTube live? Does it like show you a little corner? It automatically puts it in a Blackboard for me, which is nice. Okay, try that. Just find the slope, use the equation. Okay, I'm gonna start going down these slopes. So the first one, again, I like automatically just saying x1, y1, x2, y2. Keep it organized. 9 minus 2 over 1 minus 4, right? So 9, 1, okay. So I get 9 minus 2 is 7, right? 1 minus 4 is -3. So I get a 7, -3 slope. Now I'm going to tell you, I always write slope with the negative sign in the numerator. But fractions, it doesn't matter where you put the negative if there's only one. If there's two, they cancel, right? But if there's only one, it doesn't matter where you put it. You can put it out front or you can put it up top. It makes more sense in my brain to put it up top because it means that we go down and then I run. So that's just a me thing, okay? So if there's only there, it only works with a single negative. If these are both negative, right, we just cancel them. So it only works with a single negative, and then I always just throw it up top. And we'll see that once we start graphing some of these, what I'm talking about. It makes more sense if it's in the numerator. Okay, let's look at the next one. So we've got m equals 9 minus 2 over 7 minus 7. So I wind up with 7 divided by 0. What's that going to be? You can put it in the chat box, your guess there, what you think it is, what you think it is. 0. If I've got, let's think like this. If I've got 7 cookies that I need to share, I can't keep them. And I've got to divide them by no friends. Does that make sense? No? No. We're talking about slope. Undefined. Thank you, Jenna. From the back, okay? Jenna's correct. Look, you can never, ever divide by 0, right? Never divide by 0. It doesn't really make sense. 7 divided by 0, that is like saying, or if I had like $7 in my inheritance to give away when I die and I have no children, how much do the children get? Well, there's no children. That doesn't make any sense. So that's why it's called undefined, okay? And this is the slope for a vertical line. This is a vertical line, okay? All of these are straight lines, but this is a vertical line. Vertical lines have undefined slope, okay? So then let's do the next one. So same thing, 3 minus 3. So this puts the 0 in the numerator, 4 minus 8. So we get 0 divided by negative 4, right? Now, this does make sense. If I have nothing and I divide it evenly into my 4 children, they all get nothing. I don't have 4 children. No way. Okay, my 2 children is enough. This makes more sense, right? If I've got nothing, I divide it by something. Everybody just gets nothing. So this winds up being 0. So if the 0, yes, it is always undefined for vertical lines. Vertical lines always have an undefined slope. Always, always, always. Just like horizontal lines always have 0 slopes. Okay, this is a horizontal line. If I graph these, they would just wind up being horizontal lines. Like actually, we can do kind of a quick sketch of these. Okay, they're both positive.
Is that one called undefined too, though?
Nope, it's 0. 0's on top means it's 0.
Okay.
Yeah, so if I wanted to graph 7, 2, so if we go 1, 2, 3, 4, 5, 6, 7, 2, that's the first coordinate there, right? 7, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. 7, 9 would be up here, and it would create this vertical line, right? Here's X, here's Y. Now notice the line is stuck at X equals 7. X equals 7 is right there, okay? So repeating X values, we've got an undefined slope, vertical line. I know that doesn't look vertical because it's not a perfect graph. But then if I graph the other two, 8, 3, here's 8, 3 right there, and 4, 3, 1, 2, 3, 4, 3, we'll see it creates a horizontal line. It's a horizontal line. And notice the horizontal line is stuck at Y equals 3. Okay? It's stuck at Y equals 3. So horizontal lines like that red line always have 0 slopes. And the idea is, if we go back to the idea of slope as rise over run, there's no rise. I mean, if we think of that red line as a bank account, right? As X is getting larger, my Y value, my money's just staying the same. There's no change. And remember, slope is telling us the change. So a flat line is no change. The negative up here tells me I'm losing money, right? Every 3 months, I'm losing $7, okay? That's what that means up there. Now the undefined doesn't make any sense. That's why it's called undefined. So the blue line would be like, okay, in the 7th month, you're making infinity money and negative infinity money. It doesn't make any sense. Okay. So that's why you don't really interpret it with slope and you just give it the undefined name. Okay. Questions? We're going to use this and we'll use it to find equation of lines. If you came from like intermediate, this should look really familiar. It's something you did last semester. Or if you came from like an algebra 2 or an algebra 1 class, straight like this, actually. This should be completely familiar. Okay, so yeah, let's go into the different types of lines. Okay, so we've got 2 different types of lines we're going to talk about. We've got the y equals mx plus b, which is what, and I forgot who brought that. Lauren brought it. Y equals mx plus b. And we know one thing, right? M is always just the slope. B is the y-intercept. And it's not really y-intercept, it's where we cross the y-axis. Because the y-intercept's always written as a coordinate. So the coordinate looks like that, okay? So if we wanted to graph something in y-intercept form, so I'm kind of changing, I'll come back to slopes here in a minute, okay? But if I want to graph something in y-intercept form, let's say we had y equals 2/3 x minus 1. And this should be a big time review. We haven't gone over this in this class, have we? I feel like another class I've talked about this already. So it's kind of throwing me off. So let's graph this one. I'm going to make a graph on the side over here because I'll do a few different examples. So 2/3 minus 1. So what this means, this is my slope. I'm going to rise 2 and I'm going to run 3. And I know my y-intercept, where I cross the y-axis is going to be -1. Now look, I'm going to let you in on an industry secret here, okay? This thing is out of order. And it bothers me that no one fixes it, but it just won't be fixed. Because every time I say slope, someone yells y equals mx plus b. So it's just ingrained in math culture that it's written this way. It should be opposite. The b should be first. Because think about this. If I'm going to graph this now, am I going to graph the slope or where do we start first? Well, the slope can be an infinite number of lines have that same slope, right? Up and down. You have to start with the y-intercept. Okay, so I'm going to start there. There's my b equals -1. I know it goes through that line, or that coordinate, I should say. And then from here, I can add on the slope. So from here, I'm going to go up 2 and then over 3. Boom, right there. I know I've got another coordinate. If I wanted to keep going, 1, 2, 1, 2, 3, I'd have another coordinate, right? And I could go the other way too if I wanted to. Look, let me kind of pause here and talk about this for a second. 2/3 is the same thing as -2 over -3 as well. Okay, so if you wanted to go the other way, that means we could go down 2, your rise would be -2, and then your run would be -3. 1, 2, 3 here, okay? And look, all of those lie on the same line. We'll give it the blue color. Okay. That's this line graphed. Okay. Now let's do another one. Let's do one in red. Let's say we've got y equals -2. We'll start above here. Oh, crap. Hold on. Y equals -2x plus 3. Okay. Y equals -2x plus 3. So again, I've got to pull out the pertinent information if I want to graph out of, this is called slope, intercept form, okay? So I know my slope is -2. Now this is when I'm going to write it as -2 over 1, okay? Keep the negative up top, but I need a bottom because I need a rise and a run. And I know I'm going to cross the x-axis at +3, okay? So I go over to my graph and I'm going to go up to 3. I start there, right? And then I'm going to go down 2 over 1, right there, right? And I'm going to do it a few more times. Down 2 over 1. Then I'm going to go the opposite way. If I go down 2 over 1, that's the same as going to the left 1 and up 2. Right there. Notice, I know it's not perfect, but they all kind of lie on the line. You know, instead of red, let's change it up a little bit. I got this light green. We'll see how it turns out on the. It's not too bad. Okay. So boom, we've graphed out of this equation. Okay. I'm going to do a few weird curveballs here and use a few more colors. But are there any questions about this? This shouldn't be new, right? I'm assuming this is the review part of this section, okay? So let's do a few more. Let's say we've got y equals just 4x. So if I was going to do y equals 4x, we'll do this one in red. Now we're missing a b here, right? So we're missing a b, but that doesn't mean the b, we don't have a b. It means actually that the b is 0. So my slope is going to be 4 over 1, really steep, right? Up 4 over 1. And then my b, though, is going to be the origin. Just because it's not written does not mean it's not there, okay? We're still going to go through the y-axis. And actually, if you have anything written in this form, you're going to go through the y-axis, okay? Anything written in this form is going to go through the y-axis. It'll have a b. Okay, because it will always have a y. That's why. Explanation. So again, we're going to start at the origin here now. We're going to go up 4, 1, 2, 3, 4, and over 1, right? That's my other coordinate. And then I'm going to start here, and I'm going to go down 4, 1, 2, 3, 1, 2, 3, 4, and then over 1. And this is a really steep graph. Let's see if I can try to get it. There's a lot going on. There we go. Okay. So that's y equals 4x. So, and notice it goes through the origin because it does not have a b written there. And you're more than welcome to write 4x plus b, or I'm sorry, plus 0, if it helps you out. There's nothing wrong in doing that, okay? You're not changing anything. Adding or subtracting 0 doesn't change the equation. Okay? Okay, let's do one more weird one in this form, which is, well, what if there's no x? So what if we had y equals, let's say, 2, 3. Y equals 3. What color should we go with? I'm going to go with orange. Why not? I don't know if it'll show up. It's a little different, yeah. So a little different than that. Okay, y equals 3. Well, y equals 3 now. That's our b. Okay, so our b is going to be 3 because it's the constant. But there's no x. Now, if there's no x, again, that doesn't mean that there's not a slope. It means that the slope is 0. Okay? The slope is 0. What we have here is a horizontal line. Remember, we talked about that. A slope of 0 means we have a horizontal line. Oh, you know what? The b isn't 0. The b is 3, guys. Make sure you change that on your paper if you're taking notes, okay? The b is 3. So the b is 3, and I don't have a slope, so that means really I'm not going to rise. I can run whatever I want to run. So if I think of drawing it on the graph up here, 1, 2, 3, I'm going to start here, but then I'm not going to go up or down. I'm just going to run. Now I can run for as many units as I want. I'm going to run for 2 units. Why not? This way. And I'll go 2 units this way, okay? But that 0 means, look, think of it. There could be anything in the denominator. Any number could be in the denominator. It doesn't matter because 0 divided by any number is going to give me 0. There is my last line. It's cool. We did 4 examples on one sheet of paper, saving the universe. Okay. Any questions? So here's just 4 really good examples of graphing out of y equals mx plus b. And that's what we're going to kind of stick to equation-wise. Y equals mx plus b is the most used equation. And also, you know, quickly, what's nice about this is it's really easy to write as a function, right? Remember with functions, we talked about in that introduction to functions section, you've got to get the y by itself anyway. So if I wanted to write this blue one as a function, well, it's just f of x equals 2/3 x minus 1, right? I mean, that's all you have to do because the y is already by itself. You don't have to change anything. So so another part that's nice about this equation is that it really, in a way, is already written in function notation. Okay, it's just you just replace the y-intercept, or I'm sorry, the y value with f of x. Okay, Sherry asked for another example of m equals 0. Do you mean like another line? Like, I'll try to, oh, okay, make one. Sherry, how about this? What's your favorite number? Yeah, I'll go over this one again. What's your favorite number, Sherry? Between -4 and +5. -2, perfect. So y equals -2. Now, Sherry, between the colors purple, yellow, and light blue, which one do you prefer? Purple, yellow, or light blue? Purple, perfect. Okay. So if I was going to graph this, look, notice there's no x value. Okay, so you can actually rewrite this. Let me give it its own little corner over here. You can write this as 0x minus 2 if you wanted to. There's nothing wrong in that because there's no x value. So what that means is the slope is 0, and then the where we cross the y-axis is going to be -2. Now, really, what I need your brain to think of when it sees slope of 0 is we have a horizontal line. Okay, horizontal. That means we're not going to rise at all. We can run however we want to run, but we can't go up or we can't go down. So we're stuck. So if I take the purple pen, I know I'm going to start at -2, right? But the m equals 0 means I can't go from -2 here. I can't go up and I can't go down. So I've just got to go flat both sides. Like that, okay? So I've got to be flat on both sides. I can't go up or down. That's so I really don't have a rise up or down. Okay.
Is there a way to end up with a vertical line from that formula too?
No,
Okay.
and I'm glad you asked that, Chastity, because you have to have a y equals value. And vertical lines always have x equals a number. They'll never have a y value. So you don't have to worry about vertical lines.
Okay. On this.
And also notice that this section is labeled linear functions and slope. Vertical line, not a function, right? Because it wouldn't pass the vertical line test. Sherry, does that help? You can just type in, yes, Mr. Shirley, you're the greatest instructor in the whole world. Okay, thank you. Yeah. Great. Okay, so let's kind of keep rocking and rolling here because I'm going to introduce another equation that's going to help solve these. So this other equation, we don't really use it to graph out of. We really just use it to solve out of. And again, you should have seen this. I'm going to get some more paper. You should have seen this other equation in the past, but I'll just go over it. And typically, I don't even like this equation, but your book goes over it. I'm sticking to your book. The equation is called the point slope form. I'll tell you, the indicator to use the point slope form of a line is if you are given a point and a slope. Okay, it's very straightforward. So if the equation gives you a point and a slope, use the point slope form. But let's talk about this equation for a minute. It doesn't get a lot of love from K-12 math teachers, so you might not remember it. So y minus y1 equals m times x minus x1. Okay, that's what this looks like. Now, the m is exactly what we had before. It's just the slope. Okay, but we also have a coordinate. So we've got a point, and that's going to be x1, y1. Okay, we've got a point, and that's just going to be x1, y1. So these next few examples, all I'm going to do is put the slope and a point into this equation. I'll tell you, though, we're not going to wind up like leaving a line in this equation. We're going to try to get it into y equals mx plus b. It'll be like 2 more steps. But let's go over that real fast. So let's say, and I'm going to use an example in the book just to be lazy. This is example 2 on page 247. It says, write an equation in point slope form for the line with a slope of 4, and it passes through -1, 3. And it says put in point slope form, okay? Put in point slope form. So I'm gonna pull out the two pertinent things I need to know. I need to know slope, which it tells us is 4, and I need to know x1, y1. Okay, so -1, 3. That's my x1, y1. So if I want to put it into this form, it's just y minus. Oh man, this would have been cool in multiple different colors. Hold on. Y minus 3 equals 4 times x minus a -1. Okay. Okay, yeah, that's a little too much. That's too much color. Okay. So it's y minus 3, because that's my y1, equals m, which is my slope 4, times x minus a -1. Now look, if you've got minus a negative, that means plus, right, in math. So I'm going to rewrite this as y minus 3 equals 4 times x plus 1. So this would be the equation. This is another equation for this line, right? There's y equals mx plus b, which is great. And you can also write it in point slope form if you know a point and the slope, okay? If you know a point and the slope, you can get it into this form. Let's do another one of those. I want you to just try it real fast, just to put it in to point slope form. So let's say I've got another line that has a slope of, let's say, 2/3, and it goes through 4, -2. And I want you to put in point slope form. I want you to put this line in point slope form. Okay. Put this line in point slope form. Okay, so let's see here. I know this is my slope. That's my m. Here's my x1, y1. So I get y minus a -2 equals 2/3 times x minus 4. Okay. And then y minus a -2, I'm going to clean that up and say it's y plus 2 equals 2/3 times x minus 4. Okay. Boom. I put this into point slope form. Now I'll tell you though, I'm going to do a lot more examples of this, because the reason we do this is to get it into slope intercept form. So just a really kind of quick example, I'm going to work this out. Look, if I get to here and I want to get it into y equals mx plus b, all I have to do is get that y by itself. Okay, that's all I have to do. So once I get here, I'm going to show you, I just have to get y by itself. So I'm going to distribute the 4. I get y minus 3 equals 4x plus 4, right? Distribute the 4 to both terms, and then add the 3, and boom. I've created the y equals mx plus b, or I found the y equals mx plus b for a line that goes through 4, or I'm sorry, has a slope of 4, which we know 4x, right? And it passes through negative 1, 3. Okay, that's that line. That's really what we're going to do in the next few examples. Okay, so the next few examples, they're going to give us a point and a slope. We're going to put it into point slope form first, and then put it into y equals mx plus b. Okay, I got to get some more paper. Hold on, guys. Let me steal one from the homework. I saw that had a lot in there, actually. 2.3. So let's say, let's do number 12. This is number 12. It says, it's on page 255, number 12. Use the given conditions to write an equation for each line in point slope form and slope intercept form. So number 12, it says the slope is 4 and it passes through, so it says passing through 1, 3. So look, if I want to find y equals mx plus b, and it even tells us to do this, first I'm going to write this in point slope form. So step 1, point slope form. Okay, and the reason I even think about using point slope form is I'm given a point and I'm given a slope, right? It kind of tells us in this equation to do that. So I'm going to say y minus 3 equals m times x minus 1. That's point slope form. We did that. So the first part of that question is done, okay? 2, though, we're going to put in y equals mx plus b into slope intercept. And really all we're doing is solving for y, okay? All we're doing is solving for y. So I'm going to distribute the 4, and I get y minus 3 equals 4x minus 4, right? This looks really close to the last example we did. Add the 3, and we get y equals 4x minus 1. So the first part of the answer for this question is point slope form. The second part is slope intercept form. Okay? Questions? Comments? Concerns? Now I'm going to set one up for you. I'm going to steal one from the homework, actually. I want you to try it. So let's say, I think I can do it. Less space here. Let's look at let's say number 16 here. Number 16, the slope is -5, and it goes through -4, -2. So I want you to try that one. Slope is -5, and then it goes through -4, 2. So find the point slope form, and then find y equals mx plus b. Okay, let's see here. I'm gonna use a different color because I feel like it. Y, that's -2, so it's really minus a -2 equals -5 times x minus a -4. So I'm going to rewrite this as y plus 2 equals -5 times x plus 4. Okay, so that's the first step. I've put this into point slope form. Now I've got to get it into slope intercept form. Why not do that in red? Sure. So distribute the 5 and I get y plus 2.
How do we get 5? I thought it was supposed to be 4 times right there.
Say it again.
I don't know why. I just got confused on that one. I
Which
thought
one?
I thought it was supposed to be 4 where you have the -5.
No, the slope goes there. Right? Like here's our slope. And so the slope goes out front.
Oh, okay. Wait. All right. Why do I have that written down with a 4 in front of it?
Well, the example we did earlier had a 4, right?
Oh, it's just supposed to be M. I see what I did. I transferred that 4 over instead of an
Oh,
M.
yeah, I got you. Yeah.
Sorry.
No, that's no problem.
I get it.
Yeah. So then distribute the -5, so then we get a -20 here, right? Yep. And then subtract the 2, and we wind up with y equals -5x minus 22, which is correct. Okay. Okay. Those are two good questions on if we know the point and we know the slope, how to get it into point slope form and then slope intercept form. Man, it's hot in our office. They cranked the heat up. Okay. Questions before I just kind of keep going on and then get to kind of some kind of real world example. There's not a lot of real world examples that are straight lines, but we can make some up, which is always fun. So let's say instead of it giving a point and a slope, let's say it gives us just 2 points. So I'm going to go through the whole rigmarole here, okay? And you don't have to do all of this. This is just me because I feel like I need to do it. Let's say we pass through. I'm going to make this one up. So we might get really goofy numbers, and that's fine. Let's say -1, -2, and 3, +2, okay? And here, look, I'm going to say find y equals mx plus b. I'm still going to use point slope form, okay? But I'm just going to go straight to let's finding y equals mx plus b. Now, before I start down this path, I'm going to graph this and kind of show you how this all relates together, okay? So I'm going to graph this thing over here. -1, -2. I know it goes through that coordinate. Oh, that's kind of a little bit off, right? I know it goes through that coordinate, and then 3, 2. 1, 2, 3, then up 2. So this is our line. This is kind of what our line looks. Whoop, not that straight. That's fine. It's kind of what our line looks like, right? I know I'm going to have a positive slope because it's going up and to the right. We didn't really talk about that, but the slopes that go up to the right are positive, down to the right are negative. So it's going to have this nice positive slope. If I want to find y equals mx plus b, the first thing I have to do is find the slope. It doesn't give it to us this time, right? All the other examples before this give us the slope. So first thing I'm going to do is find the slope. And if you want to do the rise over run thing, you're more than welcome to. I'm going to just kind of quickly do it as an equation. If I did this as an equation, it would be 2 minus -2, right? 2 minus -2, that's a change in the y's, and then 3 minus a -1. Oh, this is just a nice boring slope. Nothing wrong with boring, Jesus, especially this semester. Okay, 2 plus 2 over 3 plus 1, that's 4 over 4. So if we would have done this by hand, what we would have found is we would have gone up 4, 1, 2, 3, 4, and then we would have gone over 4, 1, 2, 3, 4, right? So up 4 over 4, that simplifies just to +1. That's kind of nice. Okay. Now we've got the slope, And to do point slope form, which we have to do next, you can choose either coordinate. Doesn't matter. In the end, we're going to find y equals mx plus b. I'm going to choose this second one because it's got positive values. That's purely the only reason, okay? So I'm going to now put this into point slope form. Y minus 2 equals 1 times x minus 3. Okay, so distribute the 1. Doesn't matter because it's just 1. Winds up being x minus 3. We add 2, and we get y equals x minus 1. Okay, y equals x minus 1. So this is the y-intercept for a line that goes through these two coordinates. And we can kind of see that here, right? I mean, if I asked you to graph this, you tell me the slope was 1 over 1 and the b is negative 1, right? It's all negative 1. If we go over here, look, the b is negative 1, and we go up 1 over 1, up 1 over 1, kind of neat, okay? It all relates back together. Okay, it all goes together. But for this equation, this is what you would need to know or need to do to get this equation correct. And it takes a little bit of time. But if you're given 2 points, the first step is you have to solve for the slope, okay? And then you just use either point for point slope form and then solve for y, okay? Either point for point slope form and then you solve for y. Okay. Any questions? I'm going to dig up a real world example and do it with something like this because this, I teach this so much it gets boring. It's kind of fun looking for things in the real world where this happens. Let's look up, I'm going to Google real fast gas prices over the last year. I don't know if they've been increasing or decreasing. Let's see. Gas prices per month. This, I think this isn't the Census Bureau, but it might be the Census Bureau. Let's see. Oh. Choose. Oh, they're giving us all kinds of stuff. I don't want that. Oh, that's too much. Hold on. Man, this used to be a lot easier to use. Hold on, guys. Okay, we'll do it by year. How about that? 961, 964, excluding Alaska. Okay. No, that doesn't make sense. Hold on. That one doesn't really make sense. Oh, my Lord. Okay, let's just make one up. Let's say if we go back in the month, oh my gosh, remember those nice gas prices through the beginning of the quarantine? I almost forgot about all that. But let's kind of take those out. Let's say the average gas price in January is, let's say, $2.15. Okay. And then the average gas price in August is $1. It's probably about $1.90. Okay, I have no idea. Doesn't matter. I'm making this up. Okay. We're going to do a lot of stuff with this one. We're going to really talk about the interpretation of slope here. Okay, which turns out to be a big deal. For various reasons. Okay, so before we get to actually finding the slope and finding the equation of this trend line, we've got to decide what x and y are going to be, okay? Ooh, my x value is going to be time. Time is typical. It's really rare if time is not the x value, okay? So time is going to be months, and I'm going to use January Like you would think January is a 1, right? And so on. And then the y values are going to be the gas prices. So we've got two coordinates here. The average gas price in January is 2.15. Well, the coordinate would be 2.15, right? And then the second one, the average gas price in August is $1.90. Well, August is the 8th month, right? And that's $1.90. And we should, I mean, just before we even find the slope, what we should see is it should be negative, right? It was higher in January than it is now in August. So the trend line we have going right now is that we're sloping down. So first off, let's find the slope. So I'm going to say find slope and interpret. Okay, so if I wanted to find the slope and interpret the slope, my slope is going to be, remember this is y2, so the difference in the y is $1.90 minus 215 over 8 minus 1. So $1.90 minus 215, so that's going to be a quarter, right? It's dropped a quarter. Over 8 minus 1, which is just 7, okay? 8 minus 1, which is just 7. Now, I'll tell you, for interpretation purposes, it makes a little more sense to write this as a decimal over 1. And you'll see why here in just a second. Let me get my calculator here. So 0.25 divided by 7, negative 0.036. If I was going to round, I'll round it there. Now I'm going to think of this though as over 1. I'll tell you why. It's because of the interpret part. Okay. But either one of these would be correct. I mean, honestly, if I was going to take this on a test, now this test might be multiple choice again, or so therefore you just look to see which one's there. But what does this mean? Okay, remember the slope is telling us the change. The first part, what this is saying, actually I'm going to interpret this one. If we stay on this trend, we should see gas drop 3.6 cents every month. Now we know that's not what's actually going to happen, right? It's going to go up, it's going to go down, but that's $0.036, right? This was in dollars. So if you wanted to write, it's going to drop $0.036, that's fine. But if this trend line stays true, we should see gas drop 3.6 cents every month, right? That's what this is saying. It's going down 0.036 for every 1 month. Now that's the same as saying we should see it go down a quarter every 7 months. Okay, that's what the first box is saying. A quarter every 7 months. It's dropping on average a quarter every 7 months. Okay. Now I'm going to slide this up and I got to bring in another piece of paper because this one kind of takes a little longer. Let's see here. Let's see if you can see. We need that far. Okay. So now for part B, I want us to find the equation for this. Okay. Find y equals mx plus b. We know that m, right? M is negative 0.036. It's right here. There's a point there. It's hard to kind of see. And then you can choose either coordinate. I'm going to choose the coordinate with the 1. It doesn't really matter. The January coordinate. And I'm going to do what we've been doing before. We've got a point, we've got a slope. So I'm going to put it in y equals mx plus b and then just solve for y. So y minus 2.15 equals m times x minus 1. So even though I know the numbers are goofier now because we got bigger decimals, but we have the point slope form. Now we want y equals mx plus b. We just have to solve for y. So we got to distribute this, and I'd have y minus 2.15 equals negative 0.036x. Now, negative times a negative turns this positive. 1 times anything is itself, right? and then I've got to add 215. So I'll wind up with y equals negative 0.36x plus 2 point, okay, let's see here. The 1 would go there, 86. I should have rounded one more on that other one. That's fine. Okay. So I'd get y equals negative 0.036x plus 2.186. Look, this tells me that my trend line is going down, which for these two coordinates, yeah, it is going down, right? I mean, it's going down over that time. It goes from $2.15 down to $1.90. So if we only look at those two coordinates, it's going to be trending down. And then this tells me if I wanted to graph it, where I would need to start, okay? At month 0, which weirdly month 0 for this would be December. This isn't the best example, okay? But that is what's going on. Do you guys have any questions about this? I'm going to pull another word question out of the book that I like going over, and that's probably all we're going to have to do today. So I'll have to finish 2.4 tomorrow, but which is fine. It's scheduled for tomorrow anyway. So I want you to take your book out real fast, and I want you to turn to page 257. If you don't have your book, I can kind of show you it with, it's just hard to see the details, but I can try to show you it on this document camera, okay? It's number 92, right there on page 257, okay? Really gonna need the book because I'm gonna be referencing all these little words that are in there. Okay. So if you look at that question, and it's on percent of people calling themselves happy. You know, I'm going to notate this right off the bat. X is annual per capita income. And Y is percent of people in that country calling themselves happy. Okay, percent of people calling themselves happy for that country. So the coordinates are all countries. So if we look at this, I mean, it's really kind of a triangular shaped. Hold on, let's see if I can kind of get it a little closer there. I'm not sure if it'll adjust. Hey, not bad. Now I'm holding it, so it's going to be shaky. But notice these are all little countries in there. And if we look, if I chose a country kind of on the left, like Iran, kind of see it on the left, it's about 5,000 per capita income, and about 61-ish, 62-ish people call themselves happy, right? Where the US out there in the top right, our income's about 33% or 33,000, 32,000, and about 91% of US citizens consider themselves happy. I wonder if that's a little different in 2020. Should do a poll, might make some money. Okay, there we go. So you really need to see this on the graph to grasp it. But the question says, just as money doesn't buy happiness for individuals, the two don't necessarily go together for countries either. However, the scatter plot does show a relationship between a country's annual per capita income and the percentage of people in that country who call themselves happy. And the question states, draw a line that fits the data so that the spread of the data points around the line is as small as possible. Use the coordinates of 2 points along your line to write the slope-intercept form of the equation. And then express the equation in function notation and use the linear function to make a prediction about national happiness based on per capita income. So let's do the first part first. We need to make a trend line for this data. And if we're going to make a trend line, the goal is to cut it in half, okay? The goal is to cut this data directly in half. So I'm going to try to get back over here so you can kind of see. Okay. Now look, if I've got this data, if I want to cut it in half, I've got to make a trend line that kind of does something like this. Okay. If I cut it right there, about half the dots are above and about half the dots are below. Okay. We want half the dots above the line. So if the line's about right here, about half the dots are above the line and the other half are below the line. That's the goal of this. So I'm going to choose two corners. I'm going to do this. And then you kind of make the line in pencil if you've got it. And I'll show you what I'm talking about. So if I was going to do that, I would choose like India. Now India, I'm gonna write these in like the annual per capita income in thousands, so I can use smaller numbers. Okay. So if you look at India there, it looks like the annual per capita income is about 2.5. Okay. So I'm going to say 2.5 thousand or 2,500 really is what that is. But then the happiness is like 61. Okay, 61%. And then I'm going to cut that with like Italy. You guys see Italy there? Maybe a little. We'll do France. Okay. So if you made a line in your book between India and France, you'll see that the coordinates above and below were about even, right? Like if you're thinking like a pizza slice and you had to cut it in half, that would cut it in half, about in half. So, okay, so France though, where's France? There it is. France is about 23,000 in annual per capita income, but then happiness in France is like 80. Let's say 86. Why not? Okay, about 86%. This isn't perfect. Okay, but the very first thing it says is use the coordinates of 2 points along the line to write in slope intercept form. So we need to find the slope first, and I'm going to interpret slope. So I'm going to find the slope, but I want you to interpret it. The interpretation part is kind of the next level part. So if I was going to find the slope, difference in the y, 86 minus 61 over 23 minus 2.5. Okay. 86 minus 61 is 25, I believe. Is that right? And then 23 minus 2.5 is 20.5. Okay. And I'm gonna write this as a decimal. So 25 divided by 20.5. 25 divided by 20.5 is 1.2. I'm going to round it to 2 decimal places. 1.22. Now I'm going to think of this as over 1 to interpret it. Okay. And to interpret it, I've really got to get the units going correctly. 1 point, remember the numerator unit is the y. This is the percent happy. And down here is the per capita income. Okay. So it kind of makes, what this trend line is saying is, yeah, money doesn't buy happiness, but we can expect more happy people, an increase in happy people when we have an increase in the per capita income. Okay. So I'm gonna write down the actual interpretation underneath it, but that's what it's saying. If we would have had a negative here, it would mean that for some reason the percent happy would decrease as per capita income, like a mo money, mo problems issue from mid-90s gangster East Coast rap, actually, Notorious B.I.G. So, and Nas. Anyway, we can go back to that topic later if you want to. So let's write this out. So what this actually means is we should see an increase of, now I'm going to go with the numerator first, 1.2%, 1.22% happiness for every, now remember per capita income was written in thousands. So for every extra 1,000 in annual per capita income. Okay, we should see an increase of 1.22% happiness in our population for every extra $1,000 in annual per capita income. Of course, it's not completely true. These dots aren't all on the line, right? I mean, some of these countries are extremely happy and extremely poor, right? And some are extremely not happy and extremely poor. Like if you look at, Indonesia, Vietnam, those countries in the top left of this graph, they're extremely poor countries, but their citizens are saying they're extremely happy, right? But then on the extreme opposite of that, you've got like Ukraine, Zimbabwe, Moldova, like they're extremely poor, but they're also extremely unhappy. So there's other factors I'm sure going on with this, but this would be the interpretation. Okay, I got to speed this along. I got you for 3 more minutes. So now the question turns into, let's make a trend line, right, for it. So I know the slope is 1.22, and I'm going to use the France coordinate, okay, 23.6. I'm sorry, 23.86. And I'm just going to do what we've been doing so far. Put it into point slope form. Oh, let's act like I didn't write that. And then solve for y. So distribute the 1.22. I got to bust the calculator out. 1.22x. Now, 1.22 clear. 1.22 times 23 would give me negative 28.06. And then I've got to add 86. 1.22x plus, now add 86 to that. So 86 minus 28.06 would be 57.94. So if you look back at your graph that you made, and you kind of drew that line, does it look like it crosses about at 58? Mine does. I mean, it crosses close to 58. And with the 1.22, now remember, this is in thousands. So we would go up 1.2% and go over 1,000. It's kind of hard to see on the graph, but this would be the equation. Now, if we wrote it as a function, the y values their happiness. So I'm going to use h of x. Okay, h of x equals 1.22x plus 57.94. So remember, this was one part of the question. And then lastly, it asked, express the equation in function notation and use the linear function to make a prediction about happiness based on per capita income. So let's say we looked at Japan, which has a per capita income of, income. Guys, I'm going to go probably like 2 minutes over today. I apologize, but if you've got to run, you got to run. It's no big deal. But per capita income of 25, okay, because it's 25,000. So if I plug this in, it'll give me a predicted happiness number for Japan. So the predicted happiness number, or percent happy people. So I'm going to take that. I'm going to say 1.22 times 25 plus 57.94 is 88.9. Oh, I'm sorry, I got 0.44. 88.44. Now, if you go and look on the graph, that's a lot higher actually than what Japan actually as a percent of. The actual, I say a lot, it's close. The actual score for Japan's 80. So that's not bad. Okay. But this would be Japan's predicted score based off the trend line. Okay. Okay. Let me finish it up and give you homework. I'm just going to give you homework from 2.3. We'll do 2.4 tomorrow. So 2.3 starts on page 255. And I want you to do 1 through 1 through 71 odd. You don't have to do all those, do odd. And then I want you to skip over and look at 87. Ooh, gotta sneeze. 87 through 91 odd as well. Okay, so that's going to be the homework for today, or for today's class. Okay, great. So page 255, 1 through 71 odd, and then 87 through 91 odd. I'm going to switch this to me. I'm trying to switch this to me. Do you guys have any questions?